So this is the U substitution part 2 video. I just want to make one point to add on to our original U substitution concept. The way I taught you guys how to think about U sub is that you can use it if you see an inside as well as the derivative of that inside somewhere else in the equation. It is the inverse, it is the undoing of the chain rule. Here's what would be our inside, and look, here's the derivative of that inside sitting right there. Well, for this problem, I would definitely make my u, my inside, the natural log of x, because I have 1 over x sitting right there. So that's u sub basically done. For the second one, I would make my u my x cubed, because the derivative of x cubed is 3x squared. Well, I don't see a 3x squared, but here's x squared. So making that my u would make this problem work out. And for this one, again, my inside, my u choice would be the natural log of t, because here's the derivative of natural log of t, 1 over t. This is the essence of u sub. 95% of the time when you see an integration that you have to use u sub on, it's going to look like one of these. You'll be able to look at the problem, you'll be able to spot the inside and the derivative of that inside. Well, the purpose of this video, this part 2 video, is to address that there are some exceptions to this. They don't occur very often, but they do occur. So take this problem. This problem does not look like one that I taught you guys to recognize as a u sub. I mean, if I choose this as my inside, if I choose this as my u, I mean, what's the derivative of this inside? That's 2x. Well, I don't see a 2x here, I see an x cubed. So if you watched my first video and you encountered this problem, you would think that, no, u sub is not the right way to go here. I should try some other integration technique. Well, this is one of those exceptions. U sub can work on this one. And it's a bit weird how it plays out, so let's go through it. So I will make this x squared plus 1 quantity my u. And of course, if I take the derivative of it and I move dx to the right side, I'll end up with this. So like we were talking about in the beginning, I don't see a 2x dx. I see an x cubed times a dx. But watch how this plays out. I can split this numerator to look like this. X squared times x, well, that's my x cubed. And the reason I did this split is because, in a sense, I'm looking for an x times a dx. I don't see a 2 in here, so I can divide both sides by 2 to get that 2 over to the left side, so let's do that. So I'm looking for an x times a dx. And in a sense, there's an x times a dx buried in here. And if I split it like this, I can see that. Here it is, x times a dx. I'm splitting that x cubed into an x squared times an x. So instead of writing x times dx, I can write 1/2 du. So that was the first weird thing going on. In a way, the derivative of the inside is kind of buried in here. We just have to use that algebra to split it up to our advantage so we can see that it is actually there. So now we're here. And we still have a problem. We have not gotten all of our x's out. It's a big problem. What are we supposed to do about this guy, this x squared? Well, I mean, I either got this equation or I got this equation to help me get x's out and u's in. Well, I've already used this one. This guy has an x squared in it. So all I have to do is reorient this equation, get x squared by itself, and I end up with this. So instead of writing x squared here, I can write u minus 1 based on this right here. All I've done is taken our initial u choice and just sort of flipped it around to get x squared by itself. Alright, so now I've gotten all my x's out and u's in. And all I have to do is roll with the algebra. So this is one of those rare exceptions. We looked at our problem here, and we could not find a u such that the derivative of that u was elsewhere in our equation. At least not easily. We had to take our guy here and sort of split it up to see the derivative of that inside. And then even after that, we still had some x's left over. And what we ended up doing was falling back to our original u choice to get that remaining x stuff out of there and u's in. So this is one of those weird u sub exceptions. You look at this thing, it doesn't look like u sub will work, but it actually does, and you have to be a bit clever in how you do it. So just be aware that these weird problems are out there. Alright, let's just continue and wrap up this problem right here. So here I just moved our 1/2 out, and the way I'm looking at radical u is just u to the 1/2. Just some algebra for you there. And next, because I have a subtraction here, I can split this fraction. U squared over u to the 1/2 minus 1 over u to the 1/2. That'll get us u to the 3/2 minus u to the negative 1/2. And from there, you can just anti-derive each one of these guys using the inverse power rule. And of course, the last step would be getting u's out of there and putting the x's back in. So I would put in x squared plus 1 for each u. And that would be my final answer. So again, watch out for these exceptions here. That was the whole point of this u sub part 2 video. They're out there. It doesn't look like u sub would work based on the way I taught you u sub, but it actually does work by being a bit clever with your u choice as well as your algebra here.